In my opinion, the ultimate climax of AI will be when we would have AI powered robots. That will be the true AGI when all of these LLMs, VLMs, MLLMs will be powering these hardware. So until that marriage of software and hardware happens, I think our jobs are safe. In this video, I'm going to present you a good step in the right direction of this AGI, which is called as ClutterGen. ClutterGen is quite an interesting project. It is an autoregressive simulation scene generator for robot learning. ClutterGen efficiently generates diverse, cluttered, and physically compliant environments without relying on pre-existing datasets or human specifications. The key idea of framing the scene generation task as a reinforcement learning problem enables a closed loop mechanism to sequentially generate 3D object placements. Their policy design further enhances the diversity of the generated scene. Through both simulation and real robot experiments, they have demonstrated that the ClutterGen can help tackle several challenging robotics tasks such as clutter rearrangement and stable object placement in cluttered environments. If you look at this diagram, this tells you almost the whole story. Designing a simulation framework for robotic training typically involves a human expert observing the scene and object geometry, deciding on a placement, running simulations to check for collisions and unstable pose issues, and also adjusting placement as needed. This iterative process, repeated until object poses are finalized, is difficult to scale due to its heavy human involvement and time consuming trial and error. That is where this clutter gen helps, as it is to automate the steps for generating cluttered simulation using a single learning agent. Clutter agent controls scene generation in a closed loop manner under challenging cluttered scenarios. And as I mentioned, the key idea is to formulate the process as a reinforcement learning task. Without prior knowledge or human input, ClutterGen can generate diverse and cluttered scenes using simple reward signals. And in this diagram, you can see the whole method. They have stacked a sequence of attempt histories as input to the history sequence encoder to generate the history feature. This feature, combined with the perception feature from the point cloud encoder, is taken by ClutterGen to output the placement pose for the curate object. The simulator evaluates the placement stability, determining whether to proceed to the next attempt or the next curate object placement. If you look at this diagram, this is the example of the closed loop generation process of ClutterGen. ClutterGen attempts to place a camera on a cluttered table. Failed placement attempts, for example, floating in the air, colliding with the object, or inserting into the table, are marked by red circles. After each attempt, the simulator runs and records the movement trajectory. ClutterGen uses all previous failed attempts to adjust its future actions until achieving a successful placement. The good thing is that they have also shared a GitHub repo which you can use to train your robot. In order to get it installed, all you need to do is to just clone this repo, create your Conda environment and install the requirements. And from here you can train this ClutterGen model. Of course, you would need a good GPU and you would need your assets and all that stuff. They have also shared some of the baselines on random reject sampling, and there is a lot of good information scattered throughout their repo. And then if you want to evaluate it, there are a lot of evaluation benchmarks on ClutterGen OL SM which can be run through their provided script. So all in all, really good stuff. I think not only they have provided us a theory, the concept and all that methodology, but also some of the training code which you can readily use if you're looking to reproduce their results. That's it guys. I hope that you found it interesting. I will drop the link to the project in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.